I am Professor Prakash Jeena from the Department of Pediatrics and Child Health at the University of KwaZulu-Natal. I'm a proud alumni of the university, qualifying in 1985 from the University of Natal with my MBCHB and been associated with the university ever since. I've actually been fortunate to have fantastic mentors in the department, in the university, Prof. Kuvadia, Prof. Adhikari, and to name a few people. My interest in pediatrics stemmed from my early experiences during my undergraduate training, and I've been involved with the department ever since. I've been involved with research for the last 30 to 40 years, and I've been involved with teaching and training of students both in undergraduate, postgraduate, and for diplomats outside the university and to the community at large. I've been involved with community outreach programs which are important in actually implementing the research that we undertake. My main research activities started in '85 when I was exposed to the HIV epidemic. During the HIV epidemic, we were actually one of the first in the country to identify the first case of HIV, where we found a little child with massive lymphadenopathy, hepatosplenomegaly. At that point, we didn't even hear of HIV. And it was only after we did many tests that we recognized that this was a patient with HIV. Following that, I actually undertook to do my research in this area, and I started my PhD with HIV-infected lung disease, looking at viral infections. And my PhD was on the impact of viral infections on HIV and the lung. That particular research has shown very clearly that there is a direct relationship of HIV suppressing the immune system and allowing opportunistic infections to occur. And at that point, when I started this work, we had almost 100% mortality of children entering the intensive care with HIV. When we had that experience, we decided we needed to do something. We needed to identify what the different pathogens were, and that is when we were the first to actually identify the fungus called Pneumocystis carinii. And this was the first in Africa. At that point, people believed that children didn't get this condition. And when we identified it, we started treating for it. And the second thing we identified was cytomegalovirus. So those were the two big causes. And my research focused on that, actually to introduce the treatment for it. And the beauty of that is that since we've now done the research and implemented changes, the outcome of HIV-infected patients with lung disease entering the intensive care right now is similar to those that are not HIV infected. So we've actually turned the 100% mortality to a normal mortality that you have of children who have pneumonia entering the ICU who are HIV infected. My other interest in research was around tuberculosis. And I had started work because tuberculosis was a common presentation for HIV-infected patients. And at that point, we drew up international guidelines. I worked with the WHO, the UNICEF, and with the IULTD, which is the International Union Against Tuberculosis and Lung Diseases, where we actually drew up international guidelines around for the treatment of HIV-infected tuberculosis patients. That interest has continued even up till today, where I've actually been involved with tuberculosis. My current research is in the cutting edge, looking at biomarkers and looking at transmission dynamics for tuberculosis, because children don't transmit tuberculosis to one another, they get it from adults. And we're trying to understand this relationship in an effort to impact tuberculosis reduction across the world. So that's our major importance area. We've also looked at tuberculosis in terms of providing duration of therapy and different forms of therapy that we've actually looked at, and looked at pharmacokinetics of the drugs, whether the drug levels that we had given, whether the levels were adequate to actually kill the particular bacilli. that we're talking about. So that was my first interesting point in terms of research. The other area that I've actually been heavily involved is in antimicrobial resistance. Now, antimicrobial resistance is a major problem, and it's been identified by the World Health Assembly as one of the panaceas of the causes of death. And by 2050, there's going to be the commonest cause of death will be bugs that are got antimicrobial resistance. And our attempt with funding from UNICEF, we've actually completed studies that actually were able to define how much of antibiotics we're using it, are we using the correct antibiotics, and are we inducing resistance. Part of that process, after we've identified all of this, we were involved with developing a national policy on infection, management of infections in children, and to speak about policies of infection control, antimicrobial stewardship, and this is our current focus that we are actually undertaking. The latest being that we're going to develop an app on which you could identify patients with antimicrobial resistance early and then institute appropriate infection control measures. So that is the one major issue. The last part we've actually done is to work with the university through funding through the flagship program, where we're actually following up children, pregnant women, from conception right up to children who are in adolescence. And the purpose of that is to look at the impact of air pollution on respiratory health in children. Now, we all know that there's a whole problem about high levels of pollution in different parts of the country. In South Africa, in Durban especially, we have the South Basin. And what we are trying to do, what we have done, not trying to do, we have done this to show that air pollution has contributed significantly to the development of asthma. And what we wanted to do is to say, how are those pollutants, whether they're from motor car vehicles, fumes, or whether they're from biofuel combustion, how would they impact on respiratory health? Because we know respiratory health is the commonest cause of childhood illness. So that is the focus that we're doing. We've now applied for a major grant to look at the impact of climate change, because we know that climate change is an important confounder now with the high levels of CFC in the atmosphere, that we need to address measures of how we can mitigate the heat that is being emitted through to the ozone layer, because the ozone layer is becoming thin. How are we going to mitigate the impact of climate change on child health? And so we've applied for a major funding through the Wellcome Trust to look at the impact of climate change on child health. So those are the important areas that we're actually focusing on. In terms of my career achievements, I think the big one, as I said, is the one where we've actually looked at identifying Pneumocystis carinii as the first, and we've been able to impact reducing the child mortality from the condition. The second major impact is now we've developed policies around antimicrobial resistance and antimicrobial stewardship. And the third important area that we're actually focusing on is actually the newest thing, which is air pollution, climate change, and the impact on respiratory health. I would expect this experience to be one where we can make a difference. We can change the lives of children in this country. We are at a cutting edge of trying to make science into clinical daily living of little children, so that they become the future of South Africa. Thank you.